This is love. This is love. YouTube's not live. Pourquoi? Oh, there we go. All right, we're live. Okay, so about an hour late today. My bad. Just gonna get into it, I guess. Day 11. Week 3, day 1. Not great. We're just warming up though. Just warming up. Bad passing. Damn, gotta hit those. Gotta hit those. Let me change my sense? Question mark? Nah, JK, JK. Nice and easy now, nice and easy. Got a lot of video editing to do. Like, a lot. Come on, hit that. Cat's just dumped over there? God dang it. Alright, looks like the Stream Elements chat just caught up. 57. We want to be touching those sixes. Maybe even into a 70K. $57 again. All right, keep rolling, keep rolling, rolling. Next. Come on, I gotta hit those. Going too quick, going too quick. What are you doing? Got a blank. Got a blank. We're getting there. Climbing a bit, climbing a bit. Missing those out the gate is not ideal. Not ideal, certainly not ideal. There we go. Oh. $60. What was this? $6.27. Today's the 30th. that a high score? Yes, it is. Felt good. I could feel that one. Burr. Burr. Come on, hit these. Relax, Tommy, relax. Still 60s. Come on. Hands cramping. Little decline, but that's fine. Shit, I meant to take a slight break. $66, not bad. That would have been a new high score too. Four to go. Damn, that sucked. Relax, relax, relax. Fine. 2 to go. Definitely misclicked there. Come on, what's going on here? 62. All right. 1 to go. Stinky, 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 stinky. That's fine. Strafe shots. Oh boy, 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 boy. Do. All right, what do we got? Whoop. Tough start. Gotta hit shots. Ooh, over aiming a lot. Not great, not terrible. Small ball! Oh, come on. About the same. About the same. back here. Ooh, 82. That was fine. That was fine. Come on. Readjust. Oh, balls. $87. That was all right. There we go. There we go. Burp. What? 86. Let's just make sure that this looks good. Kick looks fine. Yeah. YouTube looking good too. YouTube, DoTube. DudeTube. $83. And that was a really slow one too. Like, it's just crazy how much. on. Wow, that still ended up being okay. I mean, just goes to show. Speed does not matter as much. Oh, but you gotta be accurate. See, I'm just throwing shots away. Bruh. Yoicks. Worst one yet. Worst one yet. $69. Gotta hit those. Small ball. Big ball. Missing big balls? Come on. Can't be missing big balls. That's even too big. Hey. What's going on? What are you two doing? Freaking cats? Oh, come on, I hit that. Hey. Hey. 69. What are you doing? Freaking kitty cats. 7, 8, 9, 10, 4 to go. Oh my goodness. Gotta hit the big balls. Need to Hit the big balls. Get over here. Come on! Oh, I hit it. I hit it at the end there. She's sticking in these 80s. I mean, it's getting my average up. High average. I hit that. Small balls. $84. Last one, best one. Last one, best one. Last one, best one. Last one, best one. Two. Small ball. Come hit that small ball. Big balls. Gotta get this small ball. How? Small ball. 69. Not the best one, for sure. For sure, not the best one. But now we go into Apex. Cloudar, aim labs. Don't know what that means. Unable to sync. Okay. Skodan. Alright, we are at 38 minutes. So at an hour 38, I should stop playing Apex. That makes sense. Math is mathing. Cat's being weird. Gun run, baby! What map is it on? World's Edge. Yeah, it's fine. Ash is fine. Let's go, team. Oh, authentic Conian the VL. Oh shit, I gotta change these. We want to go to Apex. Apex, 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 Apex. Oh hot damn, this is my jam. Keep me partying to the AM. Y'all don't understand. Make me throw my hands in the air, air. Oh, great grapple, bud. Oh, damn it, I didn't have my fucking... Alright, I gotta focus out there. What am I doing? Average Joe? This guy's better average, better name. I got the assist, baby. I got the assist, baby. What?
Themselves to be caught. Recharging shields.
Recharging shields.
Gotcha, bitch.
Recharging shields.
Giving my shields a recharge.
Oh, stinky, stinky poopy. Oh, that guy just got revenge on me. He's a revenging boy. Appreciate the assist. Oh, I got shredded. Average Joe, this guy has got my number. Oh, 6. Assist. I don't want assist. Average Joe is so much better than me. What are you doing? You only had one shield too. Oh, shredded. Absolutely shredded.
I have returned.
Hit the goddamn. There we go, baby. Not ideal. 12. We're down 4. Gotta do something here, Tommy. R9. Yeah. They call them trophy fish, so, yeah, they're pretty big. Oh. Yeah, Joe! That was decent tracking there. Accidental wall jump too.
Shields are depleted. Recharging. Their squad is approaching the building. In a trap.
Yeah, baby! Yo!
Shields are depleted. Recharging.
Come on, Joe. No! Yes! Skoden team, Skoden.
You are the Apex champions.
This is how we do it. Do that again, for sure.
I'm not afraid.
Team Death. Skull Town.
Fence them in. Fence them out. I've been shooting since I was a baby. I was a very dangerous baby.
Very dangerous baby. Gotta get the emote in there. Oh, jeez.
Echoes, take the sweet angle. Moving.
Lagging. I don't wanna. I might swap the Ash. Yo, totally not what I meant to do. Get out of there!
Echo's got an angle. Moving there. Recharging shields.
We'll take those. We'll take those assists. Eek.
Need a new angle on this.
Hey! Not ideal.
Recharging my shield. Recharging shields.
Delivering care package sponsored by Chevron.
Launching to a new angle.
Yeah, alright. We're gonna change our legend here, and I want flat.
Rumors of my demise have been greatly exaggerated.
Holy shit! Damn, son. What are you playing with? What's that gun? Oh. Car? He fucking car? Sure?
Target here. Shields are depleted. Recharging. Recharging shields.
Take the assist. Yo. I got. I got.
Rumors of my demise have been greatly exaggerated.
Not possible! Stinky poopy. Employee of arthritis.
Phase tear ready.
Actually, let's do a little.
Tracker in place. Setting a tracker. Tracker set.
Please.
Remain friends.
Stinky, stinky poopy. I am stinky poopy.
Thought I'd come back. Help out, fight strangers, whatever.
Boy jumping.
Boom! Back in sight. Back in there. Hey, stinger incoming! Watch out, enemy here.
Who? How? Dad! These two, carrying. Oh my god, again, this guy's better than me. Is this the move? Is the car the move?
I'm recharging my shields.
Alright, let's get in a game. Let's get in a game. Silver 2. Man, Mike. If I was on controller, I'd get out of silver today. Those are all. Oh, yeah. What? The challenge didn't make sense. One team, one dream.
I just polished my grapple.
It's a good day to take out some fools and be back in time for dinner. I got pork chops tonight. Yeah.
Lock and load, rinse, repeat. It's that simple.
That simple. $10, I'm the jump master.
This is your champion. Try not to
Super
touch.
dude.
You may miss me.
Alright, I'm jump master. I'll pick the party spot.
Hey up, hey up. All right, we're going straight down.
Just a thought, we could land here.
I'm
This is the
fine.
best part.
Landing over here.
Supply bin there.
Are we alone? It could be alone.
Wait, friends. My weapon is cooler now because it's enhanced. Wingman here. Using
No thanks.
Round 1. Beginning ring countdown. Attention. Mission. First blood.
Yeah, now we're talking. Let's do this. Does this enhance
Just scrap it over there,
looks
bud.
scarier? I bet it does. Rings close. 1 more minute. Extended heavy mag here. Level 1.
I need it.
The ring's
Extended
in
heavy
close
mag here.
proximity.
Level
Less
2.
than one- I need ammo here.
Whoa, not used to that.
Got extra supplies here.
Harvesters
Backpack
are
here.
now available.
Level 2.
I can use that. Ring
Extended
ain't far.
sniper mag
Half
here.
of one.
Level 2.
I can get a shield. I'll do it all. Don't worry.
Got bad guy over there. I think this place needs a little more. An enemy shield.
Friends, there is an
Shots fired. They hit me. You got bamboozled. Reloading. Alright, bam, there goes a boozle. Or something like that. You got bamboozled.
Oh, thank God.
I leveled up.
Grenade. Broken enemy shield.
Lieutenant Green will make everyone totes gels, which is short for totally jealous. Obvi. Bamboozles for the fools. Soon to be me. I think that was the whole squad. Last guy just kind of dropped.
Good job.
How'd you die?
Squad mate. Oscar Mike. I'm spotted.
Bamboozles for the fools.
Taking fire.
You got bamboozled.
Bruh.
Pop and smoke. Take it through. New kill leader. I got the banner. Let's bring him home.
We should go that way.
We just gotta keep moving.
Recharging shields.
Give me a sec. Recharging shields.
Send in a decoy. Hey, wait, how do I know that I'm not the survey beacon here?
Give my shield
I
a
can
recharge.
scan. We're probably gonna get pushed though, so just be ready to run.
I have come to the death box here.
Oh, we're good.
Positions marked on your map. Target
Thanks
spotted.
for bringing me back from the void, friend. I'm crafting.
This weapon is enhanced. Beautiful.
Let's go this way.
Dangerous.
Enemy spotted. Near me.
I got you a present. The next ring location.
I'm not over
Check
there.
your map. Something on my sleeves and what's extra supplies.
Using grapple.
Let's check out that area. Got a live one out there. Let's
I
reposition
need
there.
shields.
Spotted. Double timing it.
There's
Hit
a
this
jump
balloon
tower
if you
over there.
need.
Let's reposition.
Getting shot at. Using the decoy escape. Bam. Bam. I'm running out of ideas.
Pop and smoke. Repeat online. Let's go that way. Target spotted.
Bam to the woozle. Sending out a decoy.
Gotta go, gotta go. suck. Just leave me.
Hostile, my marker. Taking a knee. Patching up.
A fool and
Fucking
their treasures are soon
terrible.
parted.
Look at the map. The
God
next
damn it,
ring is
dude. Just hit it. Judy is booty. Judy is booty.
Recharging shield.
Hey, fuck you! Fuck!
I broke enemy shield.
You guys just run.
I got you, friend.
Bad idea.
1 minute. The ring is far.
Yeah, you should just run.
Contact with target.
You should smile more.
That's pretty sick.
A fool and their treasures are soon parted.
Hostile right here.
Enemy here. Shotgun bolt here. Level 3.
So bad. Not XP. Yo. This guy killed me? Connecting to a match. That. Shit! Support squad.
Let's make those drop kicks crap their dacks.
It's only over when it's over.
I still don't have to fight with that smiling robot.
Lots of support.
I'm just kidding, it's
Lots
fine.
of support.
Everyone's fine.
Introducing your champion.
I'm not a pawn. I'm here to break the game.
There's a prime spot for mayhem.
Might be a good place to land, but what do I know?
Oh, how's the serenity?
Support squad.
No one was going here, so it made sense.
I'll support you.
Enemy landed near me.
Front row.
Does this
this weapon make me look scarier? I bet it does.
Oh,
Serving them a knuckle sandwich.
Coming to support you.
Decoy. Wait, how do I know I'm not a decoy?
Here comes the old knuckle cluster.
Support's here, friend.
Bam to the woozle. Sending out a decoy. Getting shot at.
Sorry.
That must just have been the last one, because no one's revenging or whatever.
Hell of a kill, you cheeky dog.
appreciate it.
Using me shields.
Evo harvesters are now available.
I don't think this lifeline knows what they're doing.
Weapons enhanced and ready to dance.
In progress.
Already in that ring. I smell victory. That smells like... Tastes like pork chops. Oh, how funny. I leveled up.
I'm over here to get a scan.
And I get an upgrade. Nicer. This upgrade's made me stronger, faster, and
That's mobile.
chiseled than before. That's a word.
Sniper stock here. Level 3.
Voila. Extra supplies right here.
Shotgun bolt here. Level 3. Check it out. Care package coming in.
Check your maps.
Positions. Check your map. Spotted one. Let's go over there.
Climb. Climb.
Something on my sleeves and extra supplies.
Come.
Stay with me, Doc, and keep the healing coming.
Backpack here. Level 2.
Let's tease it out. The ultimate shot.
Optics here. Mid-range. Care package.
I'm gonna go
over
for
there.
that care pack.
Bad guys making noise that way. Eavesdropping is a skill, people.
Somebody might have just hit this care pack, actually.
Get out there and bamboozle.
Yep, this care pack's hit.
Dropships pulling in.
There's somebody here.
Bamboozles for the fools. That was better in my mind. You got bamboozled. Shots fired and they're hitting me. Reloading.
Deploying me knuckle cluster.
Giving my shields a recharge. Bam! There goes a boozle. Third. Something like that. You got bamboozled. Target's right in front of me. Back over there.
Healing. I'll walk it off.
We should push this, maybe?
Go bamboozle. I'm down.
Deploying me knuckle cluster.
Lifeline is nowhere near us.
Knuckle cluster out.
There's a squad incoming too.
If you can pick
Just
me
get
up,
up here and I'll
great.
raise
Yeah, alright.
Healing. Give me a sec.
Launching frag. Frag going long.
Last man's got your back. Target over there. New kill leader. As our boss. You're following them now, huh?
Give him my shield to recharge.
Serving them a knuckle sandwich.
Got me there.
Sending out another me. Damn, he's good looking.
Contact the target. Reloaded. Recharging my shields. Extra supplies here. Firepower.
Positions, check your map. And you're welcome. Reloading. Bamboozles for the fools. That was better in my mind.
Throwing up star.
Got one spotted.
Another squad. Enemy shields broken. Just giving my
Nice
shield.
shot.
Deploying knuckle cluster.
Stay with me now. And keep the healing coming. Yeah.
They're hitting me.
Reloaded.
Serving them a knuckle sandwich.
Bam! There goes a boozle. Go boot. Rush here to save the day. You got bamboozled. Give me my shield to recharge.
They're still fighting another team over here, right? Like we're technically a third party.
Enemy down.
Another bloody squad's attacking us.
Bam to the wood. Sending out a decoy.
No squad incoming.
Stinger incoming.
Stinger incoming. Scatter.
Reload. Healing. Oh, God.
Cracked. A decoy escape deployed. You got bam.
I'm down the hill a bit. I dropped down the hill.
I fell too. No squad down here.
Bam. Bam. Shot fire. Enemy hitting me.
Juicing shield.
Recharging shields.
What the fuck? Getting kills, so it's better than nothing. Support squad.
I just hope I don't have to fight with that smiling robot. I'm just kidding. He's fine.
It's only over when it's over.
See your support, bro, and I'll support you.
Introducing your
Jeez,
champion.
34-30. Crazy.
Be proud, mate. I'm a big bloody deal.
Good board, squad.
Victory.
Stop,
How we
stop.
going? How you doing?
I think we should move that way.
You'll find me
Let's
there.
explore that way. Right. Okay.
We got some people off rip.
Let's check out that way.
Yeah.
Close to me. Must be my enemy shield.
Knocked one.
Bamboozles for the fools. That was better in my mind.
Recharging.
Round 1. Beginning ring countdown.
Reloaded. 1 minute. Rings nearby. Listen up, I'm getting shot at.
Yo, guys, you're shooting.
Target spotted.
It's a 2v2. I killed one guy.
Got him.
Enemy down.
Enemy shield cracked.
Opening fire.
We routed that squad. Optimal challenge.
I'll get the res.
Recharging shield.
You fall down.
10. Just relax. I got everything under control.
We're chilling. We're chilling.
I leveled up. It's half past upgrading the clock. Now I better pick one. Upgrade. Spiffy. Extended heavy back here. Level 3. Deployed.
Get sniped by another team.
Give him my shield to recharge.
Good shit, guys.
Bam. I'm running out of ideas. Just gotta pass myself up.
Reload. Come on. There we go. There we go.
Rifles.
We getting landed on?
Enemy landed close to me. There's two spots right here, right in front of me. Enemy landed. Raw magnetism.
Hey, Buzzing.
I'm under fire.
Care package over there. Care package over there. You got bamboozled.
Can you call me?
Bam goes the boozle. Oh boy. You got bamboozled.
Enemy shield cracked. Exploiting an enemy's relay. I shattered an enemy's shield. The entire squad. I'm under fire.
I'm safe in this crate right now. You can be able to.
I'm not worth that guy.
Relax. I got everything under control. Alright, just relax. I got everything under control.
Fuck!
NT.
Can you really call it?
Fuck!
let's do this. It'll be fun. If not, well, you know, we all make bad choices. You live, you learn.
What you see is not what you get.
Skoden.
This is your champion.
Losing isn't fun. That's why I don't do it.
Make it good.
How about here?
Lovely.
I'll try and keep us under the radar.
But yes, okay. So look at me! Look at me! Look what I'm doing!
Look what I'm doing. Oops.
First blood. Tastes like victory.
Yeah, my weapon is enhanced. I'm ready.
Sending out another me. Damn, he's good looking.
Round 1. Beginning ring countdown.
How did I pick up
Good work.
an
We're inside
energy
the next
ammo
ring.
gun? I don't have any energy ammo. What? Well, there's that.
Opening a hold. Don't, blow up.
Yeah. Yeah.
Evo harvesters are now available.
Gotta hop up here. Standard stock here. Level 2.
Yeah, take that.
Yeah, take that.
Encrypting. DNA.
Craft it up, baby. Craft it up.
Evo harvester spotted near me.
Could have swore there was a.
There are no squads near us. Chua, I've located the enemy's positions. Check your map. I'm back. Logged off my drone. Signaling my drone back.
Money. Ready for some shield here, boys.
Hey, a new upgrade. Spiffy. Is that,
Or girl.
Do people still say Spiffy?
Warning. Ring closing.
Already in the next ring. I smell victory.
Appointed.
Smells like... Man, what is that smell? Oh, well.
New kill leader. Watch your 6.
Okay. Does this enhanced weapon make me look scarier? I bet it does.
Care package being delivered.
Check it out. Care package coming in.
Yeah, there are no squads near us.
Hit that scan, baby.
I'm back. Logged off my drone.
Get out there and bamboozle.
You want me to hit it?
Chua, there are no squads near us. I've located the enemy's positions.
Heads up. Got one here.
If we set up outside this tunnel, we can catch them coming through.
We gotta protect that spot, folks.
Okay, enhanced my weapon. Serious squads are close. 조심하자. Signaling my drone back.
Want to go through?
Attention.
Closed door here.
There is a new kill.
Taking some damage.
They found a new kill leader. Let's attack them here. Yeah, 3 squads here. I'm back. Load up my drone.
Boom. Next ring location on your map. The squad.
Well done. They've been rooms.
Just gotta patch myself up. Hang on.
Give me a second to fix me up.
There's a chance they come around.
Recharging my shield.
We're not with you there enough, boy.
There are a lot of squads around us. Chua, I've located the enemy's positions. Check your map.
Yeah, they have to come through this way.
New kill leader appointed. New kill leader.
I'm back. Logged off
I think
my
somebody's getting rezzed right behind
Enemy
us.
spotted. It looks small.
Aish. Enemy got my drone. Reloading.
Ult. Ah, bro. You're goated. You're goated.
Whole squad.
They zipped on us.
Like what I see.
Delivered.
You'll be alright. I gotcha.
I'm fine. Just fixing up.
And bam goes the boozle. Ha. Oh boy. Zipline over there. Never mind, forget that. Looks like they want to be heard. Wait, maybe they do.
Setting up a new tower.
Rings far.
Faking him out with a decoy.
Putting lead down right.
Not alone. There are a lot of squads around us.
Cracked an enemy shield.
Yo, you're insane.
Whole squad taken out. I like what I see.
Getting shot at. I'm down.
Oh, my boy.
They got me, but I'm still here.
Faking him out with a decoy.
Just us now. Gotta watch each other's back. It's on. Rings moving.
Sending out another me. Damn it, he's good looking.
No, I was not.
Attention. Delivering care package.
Care package over there. Bamboozles for the fools. That was better in my mind. Hey, max level. That's my nickname in college. I didn't go to college. Now that is an upgrade.
Full Evo cache here, folks.
Huge
Install the replicator.
Setting out a replicator.
Rings nearby.
Let's
1
check out
minute
that
till
one.
closing.
Bad guy over there.
Watching this spot.
Choa, there are no squads near us.
My ultimate's ready.
45 seconds. Rings close. Careful, they could be watching.
Would you turn invisible when you do that?
Backing out of my drone. I'm good to go. We are close to the ring. Get prepared. 30 seconds left. 조심하자. One squad nearby.
Voila, extra supplies right here.
The ring moves in.
Gotta hop up here. Extended heavy mag here. Level 3. Optics here. Close range.
Warning. Route closing.
It's on. Ring's moving.
Care package being delivered.
Ring console. Look for intel on the next safe zone.
Heard that.
Care package touching down. They usually carry rare platforms.
I'm recalling my drone.
Got you a present. The next ring location. Check your map. Care package over there. Eyes up. Dropship incoming. Gotta protect that spot, folks.
조심하자. One squad nearby.
Extra supplies.
I'm back. Brought out my drone.
Taking fire. Off the mic. I'm spotted.
Enemy shield. Enemy. That's okay. No need to thank me. Just remember that I saved you.
Fuck! How the fuck did you see me?
Bad news. I'm down.
Hold tight. I got your back.
I'll get the res.
Hold tight. I got your
I
back.
could have done it.
Troops o'clock. Recharging shield. You got bamboozled. 40. Bad news. I'm down.
No res, get out of here. No res, what are you doing? Get out of here. They pushing me? He had red shield.
I saw another Yuan. A you that won this fight, but they're long gone.
Got 10. Rings close. Warning. Ring movement in progress.
Give my shield a recharge.
Don't tell him what to do, bro. You're dead.
Spotted.
Don't play his game for him.
One minute.
Give my shield a recharge.
Goated. Goated.
Spotted.
GG's, bro. Go to the end.
Listen, let's move here.
I'm not a pawn. I'm here to break the game.
Hope you're not afraid to get your hands dirty.
Last game. Hot drop.
Breathing into the fucking.
Squad? One team, one dream?
I'm here to pour a little petrol on the situation.
Echo, ready to head out?
Twice, dude. Twice. I said a double, baby, a double quarter petrol lunch.
What?
Yeah, you worse. The young, always the young nigga.
What?
Introducing your champion.
Have you prepared for your end? I have.
Ah, looky here. I've mastered the
Oh, we're
job.
going immediately down.
Maybe we land here. Or maybe we don't. I'm fine with whatever.
Hold up.
Follow the leader. That's me.
Let's go,
I
baby.
mean, as long as we win.
Oh, yeah.
I'm going to land right here.
We should move that way.
Agreed.
Spam to the weasel. Sending out a decoy.
Oh my god, I missed all those shots.
I think this place needs a little more me.
Recharging shields.
Bro! Alright, that was real bad.
Recharging shields. I'm down. Right here, close to me.
1 minute and the ring's spitting distance. Proud of you blokes. Broke that enemy shield. Reload. Don't get too nappy. Ring's close and closing in 45. It's moving time.
Oh, they coming.
Evo harvest.
Oh, they coming.
Available.
Don't get too nappy. Ring's near. Deploying the knuckle cluster.
Alright, game dev time. Please leave the match. Game dev. Switch up the game development. Switch it up. Game development. Switch it up. Switch it up. Switch it up. Okay, what am I doing? I think I was working on the grabber.
Code. We're also going to set up a collision channel so that we can have objects respond to the grabber or not respond to the grabber. Let's dive in and see how this works. So as far as our code is concerned, it's pretty much blind. It cannot tell what I am looking at right now, and it cannot tell whether I am trying to pick up a gargoyle, or whether I might be trying to pick up something else entirely else. As far as the code is concerned, it's standing in a pitch black room and it cannot see anything. So how do we solve the problem of figuring out from code what is out there? Well, essentially we need to switch on a high beam flashlight and look in a certain direction to see what there is. Essentially flash a light into a dark scene. So imagine hidden in our dark scene, we've got these shapes here. What we might do is take a starting point and an ending point and essentially trace a line through from the start to the end and see what that line overlaps with. This is called a line trace. So when you do a line trace, you essentially can get back either a result which is all of the objects that the line intersected with on its path to the end, or you can just get the first object that it hit. And there's some optimizations that mean that if it hits an object, it actually doesn't do the entire trace at all. So this is how we often do things like shooting guns in first-person shooters, or even, like we're doing here, picking up objects. There's an alternative to the line trace, however, because the line trace can mean that we have to be extremely accurate. If we miss an object by a few millimeters, like this sphere, it won't be picked up. So the alternative is a shape trace, and sometimes more specifically known as a sphere trace, if that's the shape we're using, or more generally, it's actually known in code as a geometry trace. What we do here is we take a sphere, starting at our starting point, and as the name would suggest, we trace it, or we sweep it, actually. We sweep the sphere through the world to the end point, and if it intersected with anything along the way, then that is something that the trace will hit. So, for example, we will overlap here with this triangle and the sphere because we've expanded the radius of the search space. Now, there's one more additional thing that we can add to our traces to make them ignore certain shapes in the scene. Because, for example, we know that we can't grab hold of this wall, and maybe we want to be able to grab something through the bars, even though we might be hitting the bars as we do so. Well, the way to do that is using something called a trace channel. And this essentially creates a list of objects that can respond to the trace, and others that might want to ignore it entirely. So let's take a little look at how to set up our own trace channel so that we can pick up objects in our scene. Now, the place to go and do this is over in the Settings, Project Settings, then go to Engine and Collision, because it's
All right, we're linked. Let's go then. All right, what you got me doing now, Baba? What you got me doing now? Brilliant Filament. Dead chat, not today. Hype up your stream with Nesna.com. Brilliant Filament 6LLZ Jr. No thanks, dude, but appreciate you.
Pick up objects in our scene. Now the place to go and do this is over in the settings, project settings.
Settings. Project settings. Where are the project settings, yeah? File. What? Oh, is it edit? Project.
Then go to engine and collision, because it's all about object collision. And in here you can see we have got object channels and we have got trace channels. We're looking at particularly the trace channel because what we want to do is figure out how we should respond to a certain type of query. If we go back into our scene and click on an object, and if we scroll down to an area called collision, and there's a bunch of settings here about how this object should respond to other objects in terms of colliding with them. So if we go, at the moment it's got a default collision preset. If we have a look here, there's a lot of different collision presets here, but let's go to the custom one so we can see what is actually involved in collision settings. So we've got an object type, we've got the types of query it responds to, which is query. In this case, that's things like line traces and sphere traces and sweeps and so on, and then there's physics, so that's the simulation of physics and whether it bounces off other objects. But further down you can see there's the collision responses, and this is split into trace responses and object responses. So what it's saying is here are some of the trace channels that are already built in. There's a visibility trace channel, this is basically all visible objects, and there's a camera trace channel, which is basically whether the camera should be allowed to penetrate through this object or not. But this isn't too important. These are the types of channel that we have, and we can respond to them differently. You can see here that we can have a block option, there's an overlap, which is an intermediate option, and a completely ignore option. So this is what we're interested in. We're interested in adding in a new trace response channel here. So let's go over to our project settings, go to our trace channels, and click add new. New trace channel. Then we're going to go in here and call it grabber, and we get to choose how, by default, objects are going to respond to this channel. I want it to ignore this channel by default so that we have to specifically say that an object responds to this trace channel. I'm going to go and click accept, go over back into our dungeon, and you can see that we're not actually showing the new trace response just yet. So what we're going to do is close down the editor, save the scene, and relaunch from the uproject file. So once that's launched,
Takes a minute for me to reload, dude. Takes a minute. Do-do-do.
up, let's select our gargoyle again and go down to our collision settings, and sure enough, here we've got our new trace response channel grabber. Which, for the gargoyle, we want it to block, basically meaning that it will block the line of sight, and so it will show up in either our sphere sweep or our line trace. Great stuff. Hopefully now you've got a better understanding of line traces and sweeps. I'll see you in the next lecture.
See you in the next lecture.
Hello and welcome. In this lecture, we're going to be learning about something called the world object, a very important object in Unreal. We're going to see how we can get the current time in our game from this object and print it out to the console by the end of this lecture. So let's dive in and see how this works. So to be able to do line traces or sweeps, we need to understand another concept, another type of object that exists in Unreal Land. And that object is the world. So we've dealt a lot with levels. So if we go to our content drawer, we've dealt with maps as well. So the map and level we've kind of talked about as being synonymous. However, a world is kind of there in the beginning. In the beginning was the UWorld, and the UWorld is the type, is the class for basically the environment that we're seeing when we play a game. But it's not just necessarily one level. You can load a level, which is called a U level in C++, which is just a collection of the actors that we should bring into the U world. So you can load a level into your U world, but not just necessarily one level. You may load in multiple levels into a single world. And that's because often we have these streaming levels. We have very large levels where we don't want to load everything, every actor into the level in one go for performance reasons. So we split it up into multiple U levels, and that allows us to bring in only parts of the scene as they're required. So if we have a look at the documentation page on UWorld, I think it describes it rather succinctly that the world is the top-level object representing a map or a sandbox in which actors and components will exist and be rendered. And if you look a little bit further down, it says that the world can be a single persistent level, basically meaning a level that will constantly be there, or with potentially an optional list of streaming levels, or basically levels that can be loaded whenever we want. Now, why is any of this interesting? It's interesting because it allows us to do line tracing. If we search the documentation here for line trace, then you'll see that there's a bunch of functionality here, particularly the one that's most interesting to us is the line trace single by channel or the line trace multi by channel, which essentially allow us respectively to get hold of that first object hit or all of the objects hit by a line trace. And you can see that the list of arguments, especially if I look at the line trace single, the list of arguments has the start, it has the end, it has a trace channel for which to do the trace, and it actually gives us a result in the parameter list, which is a little bit strange, and we will be covering that shortly. But anyway, this is the line trace. We also have the ability to do a sweep. So if we search for sweep, you can see there is a sweep multi by channel. There's also a sweep single by channel. And here, as well as the start and end, you also have a collision F collision shape type that you can pass in. Basically, if we click on that F collision shape, you can follow through in the documentation in Unreal to read more about it. And you can see that F collision shape basically supports being either a sphere, capsule, box, or a line. So we're going to be using the sphere in our case, like so, and we'll see how to construct these later on. But you can see why we want to get hold of that UWorld, why it's important to us. But the question is, how do we get hold of the UWorld? And once we've got hold of it, how do we use it? Well, let's go and have a look in Visual Studio Code. On every component and every actor, there is a function called getWorld. And if you type getWorld and then parentheses, this returns an object of type UWorld. In fact, a pointer to an object of type UWorld. So let's store that. We've got a UWorld pointer, which is going to be, we'll just call it the world, shall we? And that's equal to getWorld. And then we can put a semicolon at the end there. Now, in order to actually get hold of anything from this world, we're going to use the arrow operator. So we're going to do world, arrow, and then we would be able to go and have a look at some of the details of that world. But before we do that, we need to include its header file, because otherwise this C++ file, when the compiler gets to it, isn't going to know what is included inside a UWorld type. It has no information about a UWorld whatsoever. So to fix that, we need to look at our documentation for UWorld, scroll to the top, and look for that place where it says include. And that gives us the include we need to use. You can see include quote engine / world. That's what we need. So we'll just put that after our grabber.h here. And now, if we hit control space, we should get a list of the things that we can do with this particular world. And there's many of them. We've got, obviously, we can find our line trace. We can find our sweep by multi or single. So I'd like to challenge you to print the time elapsed. This is a property available on the UWorld object. You're going to find the time seconds property, read up about it in the documentation, which is linked against this lecture, and store it in a variable.
Why don't you have grabber on you? Did it not save last time? What's the deal? Alright, clearly didn't save. Got some movers. Got some movers and some shakers. I really need this to be saved. Is grabber in here? No, of course not. Why would it be? I can't add a C++ class, but if I do it here, ooh, C++ class. Here. Where is my grabber? Here it is. It's in Crypt Raider. Run the build task. Develop and build. Grabber.
Object. Time our line trace space. We'll just put that after our grabber.8. Here. And now, if we hit control space, we should get a list of things that we can do with this particular world, and there's many of them. We've got, obviously, we can find our line trace, we can find our sweep by multi or single. So I'd like to challenge you to print the time elapsed. This is a property available on the UWorld object. You're going to
There's grabber. We see compile. Bang, bang, bang. Grabber 1, 2, 3. Does that mean I need to live code this?
find the time seconds property, read up about it in the documentation, which is linked against this lecture, and store it in a variable of the appropriate type. Again, looking at the documentation will tell you what the type should be, and then log that to the console, again, using the appropriate format specifier. Pause the video and have a go.
Pause the video. Have a go.
Okay, welcome back. So we're going to make use of this, if I search through for time in the UWorld documentation, you can see there is a float called time seconds. That's the one that I want. In this case, this is the game time, so if you slow down or speed up time, this gets slowed down or sped up as
Warp. Grabber just ain't on her. Gotta grabby Grabberson.
As well, but there are ones where that doesn't get affected. There's different ones. You've got the time seconds, the unpaused time seconds. There's also the real time seconds, which doesn't get paused or changed in any way. So I'm interested in the time seconds. It doesn't really matter which one we use because they're all floats anyway. So I'm going to create a float called time and store the world arrow time seconds in there. Now, for short, we don't actually need to put the world into its own variable. It's quite short enough to just call get world. So that's what we typically do. We'll do get world, then arrow. Time seconds like so. Now we can do a log, which we're going to say the current time is, and then we're going to do a %f because we are printing out a floating point number here, and then we can give it the time as the input into the log. Now let's go Control Alt F11 to live code, and then we're going to and then we can give it the time as the input into the log. Now let's go Control Alt F11 to live code.
That don't work for me. Takes a while to build. I don't know what to tell you. Takes a while to build. Compile that shit. Compile that shit. Compile it. Success! Except it's just not. Grabber. Okay, well. Crypt Raider .h. This is in source. Crypt Raider. Oh, yo, what the? There we go.
Code, and then we're going to open up and dock the output log and hit play.
Look at these beautiful.
And there you can see that we've got a current time which is counting up in seconds as the time elapses in our game like so. And if we actually hit the pause button, you notice that the time stops going. And if we hit play, it just resumes from where we were. If you wanted to, you could experiment with using the real-time seconds and see whether that effect happens, but I'm not going to here. We have shown that we can get hold of this UWorld object, this world object that we are currently in, and that we can get properties from it using our arrow operator. Pat yourself on the back, and I'll see you in the next lecture.
Now, why do I need it?
Hello and welcome. In this lecture, we are going to be drawing debug lines into our scene so that we can visualize what it is that a line trace is doing, or what it should be doing, and figure out if our values that we're calculating are correct. Let's dive in and have a look. So as we can see, our sweep multi by channel function requires a start and an end vector. Now, it can be a little bit hard to figure out what's going on with these functions when we actually use them, because if you start using it and you don't get back the results you're expecting, you can sometimes leave yourself wondering, well, did I ask the right question in the first place? Did I send in the right start and end vectors even? Well, to figure that out, what we're going to do is use another function here called the draw debug line so that we can definitely see where the start and end vectors are, basically by drawing a line between them. And given this is exactly the kind of thing that's going to be done by our sweep, then this is a good way of seeing, first of all, whether we've got the right inputs in the first place. So you can see here that the draw debug line requires quite a few arguments, but not all of them are actually required. Only the first 3, 4, or 5. So we've got the first thing that comes in is a UWorld, where we know how to get hold of the world now. We've got then the line start, which is a vector. We've got a line end again, which is a vector. Then an fcolor, which is something we haven't come across before, but you can click on it to find out what it is. And essentially it is a type like fvector that represents colors. And there are a few handy colors already built in for us that allow us to just say, hey, we want black, we want blue, green, whatever. You can just use a color name rather than having to specify the RGB values. And then the final few through here are whether we've got the persistent lines, which tells us whether the line sticks around or whether it goes away at the end of the frame, tells us the lifetime, so how many seconds does it stick around for, the depth priority, and the thickness, neither of which we will be using. So the other useful piece of information on this documentation page is the include. So you can see here, to use this function, we need to be using the header file that declares it, which is the hash include draw debug helpers. So let's go ahead and get that first of all, because that's going to make sure that autocomplete works in Visual Studio. If you don't have the header files, then Visual Studio doesn't actually know how to autocomplete these functions. Then we're going to go down into tick component, and I'm going to get rid of our log message for the get world, get time. We'll get rid of all of this time, in fact, and you know what? We're just going to empty out our tick function. Everything after our super : tick component, we're going to remove. And we're going to start with the draw debug line. So draw debug line and then open some parentheses. If you hit a control space, then you can see the parameters we were just talking about and some more information that wasn't available there, such as their default values. Some of them have default values, particularly after persistent lines. You can see the default value is false. So you don't actually have to provide an argument if it has a default value. But you can see that the color doesn't have a default value, so we do need to provide everything up to that point. So the first thing is the world. Little mini challenge. How do you get hold of and pass in the world into draw debug line? You do a get world parentheses, like so. Then we're going to need a start and an end. So for that, I'm going to create two variables just before draw debug line. I'm not going to fill them out just yet. So fvector start and fvector end. And those are going to be our next two parameters, start and end. And then we need to give a color. To do the color, we can do fcolor : and then we can use one of those predefined colors, such as red. There's always a good one. You can easily see it. And then in this case, because we're doing it in tick, and we're doing it every frame, we're writing this line to the screen, we can just use the persistent lines equals false. So every tick, it'll be redrawing this debug line, close the parentheses, and then we can put the semicolon at the end of the line. So what are these start and end values going to look like? Well, at the start, it's literally just going to be the location of our grabber component, because that's going to be attached to the camera. That is a good start location. Now remember that there is a forward vector for this component, for the camera, for the grabber, and that forward direction is going to be pointing out from the camera, out into the scene, always pointing forward. So what we want to do is take our start vector, add the forward vector multiplied by some amount. Basically, that some amount is going to be the maximum distance that we are going to look for the object. So you might have 1 or 2 or 3 meters as the amount, and then we're going to end up with an end vector. So the start plus the forward vector of the grabber is going to equal the end vector. So that maximum depth that we want to look into the scene is something that we might want to configure. So we'll put it as a uProperty on the grabber.h. Let's go over to the grabber.h and create a private section, make a uProperty that we're going to make edit anywhere. And then we're going to have the type be of float so that it can be any numerical distance. And we're going to call this the max grab distance. And we'll set it to a distance of 4 meters by default. Maybe that'll have to be 400 because the default unit is centimeters. So I'd like to challenge you to calculate those starts and ends. Use the get component location in the first 400 because the default unit is centimeters. So I'd like to challenge you to calculate those starts and ends. Use the get component location in the first instance, use the get forward vector to calculate end, and multiply by the max grab distance that we have just configured there. Then compile, play, and eject from your actor, because this line is going to be going straight down the camera. You may not see it initially. So eject, come and step out of your own body, and can you see the line? Pause the video and have a go. Okay, welcome back. So let's go into the Grabber CPP and start writing what we're going to put in start. As we said, this is simply just going to be the get component location, and then the end rather, is going to be the start plus the get forward vector multiplied by the max grab distance, like so. Put a semicolon on the end of that line. We're going to go ahead and compile, and if it compiled successfully, let's go ahead and hit play, and then get
on with it. Building 28 actions. Kona. Hey! Stop it. Yeah, you. Ooh, failed. Okay, what is it?
the header files.
Draw debug helpers? What did I say? Draw include helpers. Another 20-minute compile. Manual recompile triggered. Billing 28 items. Yes, linked. Let's go.
Then at the start section, make a U property to calculate. Okay, welcome back. So let's go into the Grabber CPP and start writing what we're going to put in start. As we said, this is simply just going to be the get component location, and then the end rather, is going to be the start plus the get forward vector multiplied by the max grab distance, like so. Put a semicolon on the end of that line. We're going to go ahead and compile. And if it compiles successfully, let's go ahead and hit play. And then get our mouse in the viewport, hit F8 to eject out. And if we step out of ourselves, you can see the line clear as day coming from where our camera was all the way down into the floor. And probably if I come out, we may even be able to see that it's poking a little bit out of the bottom of the floor as well. That's 4 meters for you. So we've got a start, we've got an end. And if we were to use this line, this would be an excellent one for the input parameters to our geometry.
Ah, so Grabber is not supposed to be on Shishon. Grabber should be on Shishon. VP real char first player. Yeah, that's right. Oh.
Sweep that we're going to be using later on. Great stuff. We've learned.
So this is not actually where I'm like. It's not on the fracking first person camera component. Ugh. Capsule component. Wrong. Character mesh. Still wrong. There's person mesh. A little better, but first person camera component. It is moving with the camera. Oh fuck. It's just low. not looking. Whatever, not perfect.
How to draw debug lines into our scene. This is a very useful skill that you'll use a lot when you can't understand why something is not working. I hope you enjoyed it. I'll see you in the next lecture. Hello and welcome. In this lecture, we are going to be learning about references, an alternative to pointers. And we're going to see why they're different, why we might want to use them. Let's dive in and see. So as well as pointers, there's a very similar related concept called a reference. Now, both pointers and references are essentially just a memory address. They both store a reference to where another variable can be found. And in this way, they are incredibly similar. The difference between the two comes to basically down to whether they can be reassigned. Basically, can they point to a different address after they've first been created? In the case of a pointer, that answer is yes. You can change a pointer to point to a new memory address, a new actor, a new component, whenever you like, as long as it has the right type. A reference, on the other hand, can only be set up once when you first create it to point to another variable. It can't then be changed again. And this is a safety feature because repointing variables can lead to problems where those variables might disappear or where you set that pointer to null. A null pointer is essentially a pointer that points to nothing. And trying to do stuff with a pointer that sets to nothing can actually crash your engine, which isn't an ideal result. With references, because you have to give them a value when you first create them, they can't be null, so you cannot get these null pointer crashes. So let's start to have a look at some of the syntax involved. So when you access content with a pointer, you have to use some special syntax. You have to put this star in front of the pointer to make sure you're getting the value in the pointer, not the memory address. With references, because you never really need to get hold of the memory address, you can just use the variable as if it was the variable it's pointing to. You don't have to use any special syntax. Now, there's accessing the address. So with pointers, you get hold of the address automatically when you use the variable. With a reference, you have to use special syntax to do that. You have to use the address of operator, and it will get you basically the same address as the original variable. And then there's changing the address. With a pointer, we've seen that you can assign the address and use the address of operator to do that. With references, this isn't allowed, so there's no syntax for it. And finally, what if we want to change the value that we're pointing to? Not the address, but the actual value being stored at that address. Well, with pointers, you've got to, again, use some special syntax. You have to put that star and then assign something. So the actor pointer, you assign to the star actor pointer. With references, again, because you can't change the actual address, you don't need any extra syntax. We can drop the extra syntax and just have the actor reference equals actor, means that you are overwriting the value in the pointed to location. So that's all a bit theoretical. Let's have an actual example. So if we had a float that was perhaps storing the damage done to us in the game, and in that we are storing the current damage is set to 0. No one's done any damage to us. Now we might want to create a reference to this to, instead of copying it around, we might want to pass it into a function but without actually changing it. The way we can do this is to have a float and then put the ampersand after the float, and the ampersand says that this is a reference to a float. It is not a new float itself. It doesn't allocate any float memory, it just allocates pointer memory. And so we can call this the damage ref, and we can set it equal to damage. We don't have to take the address of or do anything like that. It automatically knows, well, this is a reference and this is a variable, so what you're trying to do here is set up a reference to that variable. And sure enough, if we go and ulog, then we can print this as if it were just a regular float. So we can say damage colon and then %f, and then here we can do just print damage ref. We don't need any special syntax. We can use it just like a regular variable. Let's go ahead and hit play after compiling, have a look at our output log, and sure enough, the damage is coming out at 0, which was the value that we set. But that doesn't necessarily prove that I haven't made a copy of that original variable. So I'd like to challenge you to try changing the value and see what happens. So use the reference to damage to set a new value, and then print out the original value too. So the original value next to the reference value.
Shouldn't have compiled. I jumped the gun. It takes 5 ever. Damage up. We'll do / new line. Is it that or is it this? Damage. We'll do damage. Build failed. Oh no. Oh no, oh no, oh no. Restart it. Whoa.
And have a look, are they the same or are they different? You only change the reference, but does it change the original as well? Because that would imply that they are both the same variable. Pause the video and have a go. Okay, welcome back. So let's give this a stab. So to change the reference now, we're going to do damage ref equals, and this time I'm going to say that we did 5 damage. And notice I haven't had to use any special syntax here. It's not repointing the reference because we've already declared it and set its reference up on that first line when it's created. We can't do it again, so now we can just be setting the value. So what I can do now is we've got the damage ref is in the log. Let's also put a damage and %f onto that same string and then pass the damage in here as well. And then we're going to compile and have a look. Let's hit play, go into our output log, and sure enough, it's printing out damage ref and damage as both having the new value that we've set, the value of 5. So in essence, what we've got here is 2 variables that point to the same piece of memory. You could almost say that they are the same variable but with different names. So this has the benefit of not needing a copy, just like a pointer, but it also has a lot more benefits because it's so much easier to use. We don't need all that extra syntax, and it's also safer to use. So as long as we don't need to repoint anything, using references is generally preferable. Now let's do a quick review of some of the symbols we use here because they can get a little bit confusing. They're used a lot in C++. So the ampersand and the star symbols, let's have a look at them in context and what they mean. So when we are using them, so when we are using them in an expression, here are some code examples. You might see the star before a variable, you might see the ampersand before a variable. What does this mean? Well, with the star symbol, the syntax of putting it before the variable means we're getting the contents at actor pointer. Now, with the ampersand, if you put the ampersand in front of a variable or in front of a reference to a variable, it's saying that it's getting the address of that variable. It's getting the address of the actor or the address pointed to by the reference. Now, when we are declaring, like when we're using it in the type of a variable, the stars and the ampersands have almost the opposite meanings. So the star means that this is a pointer to a U actor, and the ampersand means this is a reference to a U actor. So just remember this, that there is a completely different set of meanings whether you're using them with a variable in an expression or whether you're using them in the type declaring a variable. Now, I won't go into it in too much detail, but to add insult to injury, these can actually have other meanings in other contexts. That ampersand can mean a bitwise and. The star, as we've already seen, can be used with strings in the U log. So this isn't necessarily all of the meanings of these two symbols, but they are pretty much all the important meanings referring to pointers and references. Great stuff. So we've learned about pointers, references, how they relate to each other, how they are different, and why we might want to use them. I'll see you in the next lecture. Hello and welcome. In this lecture, we're going to be learning about a strange phenomenon called an out parameter. This is a parameter that instead of passing the value in C++, we tend to pass the value out of a function. And we're also going to see about something called a constant reference and how these two concepts are kind of intertwined with one another. Let's dive in and figure this out. Now, the real place that references shine is in parameters to functions, because every time we create a float delta time like this in our tick component, what we're doing is we are taking a copy of that original float and we are passing it in to the function. So instead of doing that, what we might want to do is take a reference to it and pass that in instead. So let's imagine that we were to create a function in Grabber.h called print damage. And as a argument to this function, we want to pass in a float damage. Now this, as I said, is going to make a copy of whatever we pass in and copy it into that variable created, this parameter variable, inside the print damage function. And we do need to have a return value of void here as well to complete it, and a semicolon at the end. Let's go over into the C++ and continue this conversation. Let's create the print damage in here. Let's put the uGrabber class in front of it, and let's put some braces instead of the semicolon. So we've got a copy into the damage parameter variable. And it's safe because if I were to do damage equals 5, I'm only changing this variable here within print damage. I've got a copy of it to my own. I can't mess it up by accident. Now, what if I didn't want to make a copy? My alternative would be to take a reference. So what I can do here is I can put a float reference going into print damage, and I need to update that over in the C++ file as well. And then I might have this log message that we're using the reference for. Let's go and take this down and put that into print damage. So now we take our damage and we're printing it out. Let's update the log statement to say damage is this. Okay, so damage is this damage. And in our tick component, what we can do is we can do print damage and pass in our damage variable and put a semicolon at the end, and we can get rid of our damage reference for now, because what we've got going on now is a damage float. It's created in tick. The memory for this has been created here in tick. And then we go and give it to this print damage function. But because the parameter is a reference, we aren't actually copying this damage. We are taking its address and storing that in the reference instead. So that when we use this reference down the line, we're actually accessing the original piece of memory. So no copy has had to happen for this to print the damage. Now let's just check that this is actually doing what we would expect it to do. If I change the damage value to 5, for example, and then recompile and hit play, and then go and have a look at our output log, indeed it's printing that the damage is 5. But because we've got a reference, we know that we can update that value. So what I can do is I could say within this function, I could do, hey, damage should be equal to 2, like so. And if I wasn't careful, if I thought I had my own copy, I might think that's okay. But actually, in the tick component, what we've done is we've changed the original variable. So if I put a ulog in here to inspect that original damage variable, and we put %f and pass in the damage here, let's live coding compile that. And we're going to hit play, have a look at our output log, and you can see that now the damage and the original damage have both been modified. They've both been changed to the number 2, which isn't great. You know, you could accidentally do a lot of damage, if you'll excuse the pun, by changing variables that you weren't expecting to change. And here comes another use of that const keyword that we've seen in the past. If I stick const in front of my float reference, then what I'm saying here is that this should be a reference that you cannot change. You cannot call any non-const functions on it. You can't set it. You can't in any way change the contents of this variable. You can only use it. You can only read it. You can only see what is in there. So if we go back into our Grabber CPP, we need to make sure that we put const here in the parameters as well. And we can go ahead and compile, and you see we get a build failure. And the error is saying that damage cannot be assigned to because it's a const variable. So that gives us the protection we need. So generally speaking, if we are trying to pass a variable in an efficient way where we don't want to take a copy, then we will always use the const keyword as well as using a reference, because this prevents us from accidentally changing that contents. Now, however, sometimes you do want to use it to change that value. And what we might have as an example, we might have a Boolean return value, and we might want to say has damage. But we might also, as we've done in Blueprint in the past, want to have a second return value. So we might say, have we got any damage? And what is that damage? Well, in this case, it actually makes sense to use a simple non-const reference, a float reference to the damage. And typically we would actually call this out damage, just to make it really visible that this is what's known as an out parameter. It's not a parameter for passing things in, it's a parameter for passing things out. Now, it can be a little bit of a weird quirk of C++, and it can be hard to spot. But generally speaking, if you see any parameters that are a reference but aren't marked as const, then you can pretty much assume that somebody intended to use that as an out parameter. So that's what we've got here. We've got has damage, and if we were to go and implement this over in the CPP, then we can put the uGrabber class in front here, and we can put braces, parentheses here. We're going to comment out the line in print damage what it's not happy about, because we're trying to set a const reference. And essentially what we could do in here is we could do some code, we could see if we've got some damage, and then we would print out, yes, okay, out damage equals 5, so that's the damage that's been done. And we're going to return true because we've got some damage that's been done. And this we can now use in somewhere like tick components to get hold of the damage. So here, instead of setting the damage 5, we might get the damage and print it if there is some damage. So we can say something along these lines. If has damage, and then we pass in the variable that we want to be populated with the damage, so damage, for example, and then we can have the body of our if statement, and we could only call print damage, for example, if there is any damage to be displayed, and we can remove this ulog entirely. So this is the way that we use non-const references as out parameters, a way of getting multiple return values out of a function. And typically when we do this, when we are calling to this function, we will create the variable, but we won't give it an initial value. So on line 39, basically I've got a float damage defined. I pass it in straight away in the next line. This is another telltale sign that you are using an out parameter. I haven't given any value right before I've passed it into a function, means that I'm expecting that function to put the value in for me. So this can be hard to spot at first, and it can be a little bit confusing, but these are the two rules that I would like you to remember. If you see a variable declared and not given a value and instantly passed into a function, ask yourself whether that's an out parameter. And the other rule is if you see a reference as a parameter, but it isn't const, then that might also be a hint that this is an out parameter. And of course, if the variable or parameter is named out something, then that's a dead giveaway that this thing is meant to be an out parameter. Great stuff. I think that's set us up very nicely for being able to do a sweep. So I'll see you in the next lecture.
See you in the next lecture.
Hello and welcome. In this lecture, we're going to be setting up our first geometry trace so that when we go and look at our gargoyle, we get close enough within range, then sure enough, it prints out the name of the actor that has been hit by the trace. Let's dive in and see how we can do this. So we're finally ready to tackle this sweep single by channel. There was a lot of pieces that we had to have in place to make it work, but finally we're here. So let's have a look at the syntax of this function. So we are in a much better place to understand what was going on here when in these types. So the return value is a Boolean, which basically tells us whether or not we found anything with the sweep. Now, the second argument, as you can see here, it's a reference. It's got this ampersand, and it doesn't matter whether there's a space after the ampersand or a space between the variable name. It's all the same as long as there's an ampersand after the type, saying that that type is a reference. And it's a type called an f-hit result. You can see that it's a struct. So this f-hit result is the out hit. That is the result that comes out of the sweep. We can see what things have been hit, and it's a struct because there's multiple different things, pieces of information that can come out of this sweep. Then we have a const f vector reference. So this is taking our start vector by reference instead of copying it. Same with the end vector. Then we've got a rotation. So this is the rotation of the shape using an f-quat, which is an alternative struct to using the f rotator. We'll see how we can basically just put in a 0 rotation here because we're using a sphere. It doesn't really matter. The next thing that comes in is the trace channel, and we'll see how to figure out what our trace channel is called in C++. And then we've got our collision shape, which will be the last argument we need to provide, and we'll see how we can create a sphere of a certain radius by doing that. But before we begin, we'll need to know what that radius is and have it configured. So we're going to go over into our grabber.h. We're going to remove these functions we've been using as examples for .h. We're going to remove these functions we've been using as examples for const references and out parameters, and we're going to create a new U property, which is going to be edit anywhere, and it's going to be a float called the grab radius, and we're going to set that to 100, 1 meter. So let's go over into the C++ now and remove the references to print damage and has damage, and we can remove any of...
Oh, you just fall?
To 100, 1 meter. So let's go over into the C++ now and remove the references to print damage and has damage, and we can remove any of that from the tick component as well, the whole if statement and where we're passing in the damage. Because here, we're drawing our debug line, and now we want to make damage. Because here, we're drawing our debug line, and now we want to make a call to our sweep single by channel. So we're going to type sweep. So we're going to type get world parentheses, because we know that this is a function on the uWorld object. Then we're going to do an arrow, because we know that get world returns a pointer. And then we're going to do a sweep single by channel, like so. And we're going to have to input an out parameter for it to populate as the first argument here. So we're going to create a variable that's going to be empty that will be populated, and it's got to have the right type. So it's going to be an if f hit result, and we're just going to call the variable itself hit result. Put a semicolon at the end because we're not initializing it, we're not giving it any value, but we're going to pass it in for it to be given a value by the sweep single by channel function. So that's our hit result. Then we need to pass in the start and end vectors, which we know are going to be not copied, but taken a reference to. Now we need to populate the rotation, which we can do with a simple fquat : identity, which tells basically that this is a no rotation. That's just a bit of a weird language for it. It's a mathematical speak for meaning that this is no rotation. Next up, we need the trace collision channel. Now, how do we go about finding that trace collision channel? Well, if we go over to the folder that holds our project and we go into config, and then we go to the default engine ini, right-click that, and go open with Visual Studio Code. And in here, I'd like to search for grabber. So you'll be able to see the collision response channel for the grabber, and it's basically been set up here in the default engine, ini. It's only mentioned once in the whole file. And you can see the channel name. This is the channel name in C++. It's not very obvious, but it's ECC Game Trace Channel 2. So we can go...
Need to go to the config file.
Engine ini.
Point view details. Why are my details showing? Rename. New. Oh, it's just gonna be this one.
Right-click that and go open with Visual Studio Code. And in here, I'd like to search for grabber. So you'll be able to see the collision response channel for the grabber, and it's basically been set up here in the default engine, ini. It's only mentioned once in the whole file. And you can see the channel name. This is the channel name in C++. It's not very obvious, but it's ECC Game Trace Channel 2. So we can go ahead and copy that, and then we can go back to our grabber CPP and paste it in here as the trace channel that we want. Now this line's getting rather long, and what we can do to compensate for that is we can actually put each of these parameters on separate lines, or at least to spread them out. So maybe the start and end are on the same, the identity quaternion is on one line, the trace channel is on another line, like so, and that just gives us a little bit more space for reading these long argument lists. Now if we head back to the documentation, we can see the next thing we need to pass in here is an F collision shape. So we need to construct a shape. Maybe we'll do this as a separate variable up at the top. I'll just do it before the F hit result to make it super clear that the F hit result is actually an out parameter. I'm always going to leave that as the last thing before the call to the function. So we're going to create an F collision shape, which we're going to call the sphere. And we're going to set it equal to F collision shape : make sphere. So it's going to create us a new sphere collision shape, and the argument to this function is the sphere radius, which we have got as the grab radius variable that we've configured as a U property. Put a semicolon on the end of this line, and we can pass in the sphere as our final argument to the sweep channel function and put a semicolon at the end of that line. Now, one more thing is that this function we know returns a boolean, which is whether we've hit anything. So I'm going to put the result into a boolean variable called has hit, and that's what we're going to be using later on in this function. So I'd like to challenge you to print the hit actor's name. So now we've got this sweep happening, we should be able to get some results out of it. So use an if statement to print if we have anything at all. So if that boolean is true, that's when we're going to print out the actor name. You're going to get the actor that the sphere trace has hit by using the hit result struct. It's got a method on it which you can access with the dot operator, because it's a struct and it's not a pointer to the struct. You can do a dot get actor and use the parentheses, and that returns you an actor pointer. Then using the actor pointer, you can get the actor's name using the get actor name or label method.
Compile. Building 28 action started. Ugh. Fail, fail.
And think about whether you want to use the dot or arrow operator for this, and then compile and test having printed out that actor name and see what you can hit in the scene. Pause the video and have a go. Okay, welcome back. So we're going to start off with creating that if statement. So if has hit, then we're going to put some braces, and we're going to do, first of all, we want to get hold of that actor pointer. So a actor star hit actor is equal to the hit result dot get actor parentheses, like so. Then we're going to do a ulog, and we're going to write hit actor colon %s, and we can do hit actor, and because it's a pointer here, we can do hit actor arrow get actor name or label, then some parentheses, and because this is a string, we have to put a star at the front of the whole shebang so that it can properly display it in our UE log. Okay, so we
Compile for me, baby. Error, error. Float damage, unreferenced local variable. Come on, dude. Boo. Come on, just freaking compile here, man. Error, error.
Every second you stay here, your odds get worse and worse. This is Pirate Island, after all. To get to the source, you think I can't sink my claws into that ship you got waiting off the coast? Right, what the?
Something that's a Tina-ism is Tina is usually the last to leave.
Well, I've heard this.
Why is that? Are you just a late night bird?
You know, I have birthday party trauma, so
Okay.
whenever someone throws a birthday, when people leave, I'm like, what if they get sad and anxious? And so I like to be there.
Wait, what's your birthday party trauma? Did that happen to you?
Well, I have a summer birthday, June 30th. One time I invited all my classmates, and only my best friend and this one guy showed up. And I was like, ooh. And my parents like spent all day hanging out with streamers.
Which one? Passing yards? Okay. So I still have the touchdown record, right? What? Great.
Come on, man. Come on, man.
We're gonna flank round through market. Come market, two market. Two market.
Successfully linked batch.
Now need to just go ahead and compile this. Then once we're in the scene, let's open up the output log and dock it to the layout so we can see it while we play, and hit the play button. And instantly you can see that we are hitting that gargoyle statue. If I turn around and look at something else, you can see, well, it's not very clear whether I'm not hitting anything or whether it's displaying nothing. So what I'm going to do is I'm going to put in an else to our if statement here, put some more brackets, and I'm going to do another ulog. And this time the text is going to say, no actor hit. Let's recompile and go and play it in the editor. And you can see now it's saying no actor hit all the time until I go and start looking at the gargoyle. And now it's saying that the gargoyle is the thing being hit. If I move too far back out of our 4 meter range, you can see that it's saying no actor being hit again. Great stuff. So we have now done a geometry sweep with a spherical object, and we can see that it is indeed reacting only to the actors in our particular trace channel, such as the gargoyle is the only one that we've set up at the moment. So that's the only one that it's finding. I'll see you in the next lecture.
Okay, I think we're gonna pause here. Because I think we're hitting that hour mark. A lot of compilation time.
How long are you a legal secretary?
24 years this spring.
You good at what you do?
I'm great at what I do.
Then you start tomorrow.
Mr. Spector, I wanted to
You're still here?
I don't leave until you leave.
Well, in that case, what time is my meeting with you?
11:15.
Did you line up?
Fine. I did, but not for another week. Not getting Puma.
Ever feel a little guilty about you? Watch this. Watch this. Ready?
You're on me.
He's here. I'm taking point on him.
Oh my god, take two. You got him?
He gets hit. Watch this. Watch this. And Thomas sends one to straightaway center field. It is up. Soto's had pretty good success against Chen. I don't know about trying to bunt a hit over the mound, but he just did it.
Things in his mid. Apparent. Pops up this bunt. My goodness. And bunts it over the head of the.
There we go. Pick it up. Alright, file, save all. Alright, yay! Great, 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 great. 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 Save the grabber. Great. Hello, hello, Java Edition, oi. Ding, 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 ding. There's no place I'd rather be than on a surfboard out at sea. Search till the sunset beyond the horizon. Flying high on the Hawaiian roller coaster ride. Oh, let's change all the settings. Let's change this here now. Doody 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 doody. I did a doody doody doody. Minecraft. Yes. Love the music. Yes. What am I doing today? Oh, we're building. Let's go, team. Fuck. Ursha, baby. Oh, I meant to plant those trees. Oh man. Do have a trial spawner there. Is this Deep Slate? Oh. It is. Cobble Deep Slate. Not Deep Slate. What's going on? Wait. Iron. Lava's popping. Ooh. Hey. I've been here before. Yeah, baby. Just go into this wall here. Give me all of that. All that. All that in a bag of chips. No left behind. Burp. Eerie noise. Why? $64 divided by no. Yeah, give me some tunes, Craft. Give me some tunes, Minecraft. We're crafting, baby. Actually, we're mining. We're not crafting. Jesus, this hits hard, brother. These tunes they go hard. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This is definitely more than enough. Anything down here that I want to grab, though? Ow! I mean, do I want to try to go get a... Sprint! Let me just peek our head in here. Zombie! Yo, chill, bruh. Oh fuck, I'm not ready for this. I'm not ready for this. Holy shit balls. These motherfuckers are poisoning me. No, I don't want to do this right now. Too intense for me, brother. Too intense. Hey! Spruce. Cobbled deep slate. Here, I won't cook that. We can plant these sappers. You can't blast furnace this? God damn it. Ow! Who did that? My boy. Okay, I need... Okay, I think I'm just gonna go on feel here. Just gonna put down. Deep Slate, are you yoinking my Johnson right now? Hey! Okay, that's kind of hilarious. Cobbled, cobbled, cobbled. Regular. How does this look? Wait. Does this not strip them? I should be stripping this. So I want to go another way now. I mean, the house doesn't need to be crazy big. But maybe it should be. Okay. And then 1, 2, 3, 4. Dun, 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 dun. Main entrance. Hey. Kitty cat. All right. Actually, fuck. I'll make it out of dark oak. I think. I don't know why I have this shit in here. Should just throw it all out. Dark, dark, dark. Spruce. Dark, dark, dark. Shit down there. Fuck. Hello? What's up? I'm in here. I'm still streaming. Hold on. Alright, I'm calling it.